configuration, you would never see this outside like this. But in the shuttle program, when they were building up what we would call the stack consists of the two solid rocket boosters, the external tank, and the orbiter, which makes on this side. This stack would be in the vehicle assembly building. They would start with the two solids on either side. They build those up, and then they attach the external tank, and then they attach the orbiter. And that would then be rolled out from the vehicle assembly building out to either Pad A or Pad B, depending on which one was allocated for that mission. So this is unusual to see this out in the open like this, because you would never see it like this. It would only be inside a building in this configuration. But these are the most powerful solid rocket motors ever produced. And for the Space Launch System, the next launch vehicle that NASA is building, it will be based on these rockets with an additional solid propellant segment added to the top. So those then will become now the most powerful solid rocket motors ever built and used. The solid rocket boosters would burn for approximately 2 minutes on a shuttle launch, and they would be jettisoned by these 4 solids that you see. These are booster separation motors that you see here. And up at the top, there are 4 more at the top of the nose cone. And those 8 motors would push the boosters away from the stack and get it away from the vehicle so that there would be no recontact. It would be very dangerous if any of these even grazed the orbiter after they separated. So those motors are to ensure that the boosters get a safe distance away before they start their recovery. The propellant tank that you see here fed the main engines. There are 3 main engines on the back of the shuttle orbiter, each producing about 330,000 pounds together. It's just right around 1 million pounds of thrust. These are producing close to 3 million pounds of thrust apiece. So it's roughly equivalent to what a Saturn V produced. It's slightly less powerful, so shuttle could not make the claim that it was more powerful than the Saturn V. It was just slightly under. But the dynamics of a shuttle launch were greater than a Saturn V because of the solids. The solids produce a more thunderous roar than liquids, and because of that, you actually were feeling the earthquake seemed larger when a space shuttle took off. So after these would separate, the main engine would continue to be fed by the propellant in this tank. Everything would light on the ground. The main engines would come up. When those were determined to be good, then they light the solids, and off it goes. After 2 minutes, those separate. The propellant tank continues to feed the main engines for a total of 8.5 minutes. When that is depleted, it is jettisoned, and then 2 small orbital maneuvering system engines fire, and that gives it the final nudge to get it to orbital speed so that it doesn't fall back to Earth. So that's basically how the ascent the ascent profile went. The boosters would go through a parachute recovery sequence. They would land in the Atlantic Ocean. One ship would be dedicated to one booster, another ship would be dedicated to retrieve the other booster, and they'd fish them out of the Atlantic, tow them back to Cape Canaveral, and start refurbishing them for another space shuttle mission. The external tank was dropped in the Indian Ocean, and it was not recovered. So they expended one of these on every mission, never recovered any of those tanks. One more thing I will point out, there are 8 points on the pad surface that this entire vehicle is secured. 8. And where you see that silver device right there, that's one, what you would call a hold-down post. There is a frangible nut underneath that covering. The frangible nut is about as big as my 2 fists put together. So there's 4 on that booster, 4 on that booster, and that is the sum total of holding down and 6 million pound, 5.5 to 6 million pound hunk of hardware. And those nuts, when the firing command is given to light the solids, there are 2 tiny fractures deliberately drilled into or cut into the nuts. And there's a little explosive charge where each of those are. And the nut's this big, there's a charge on this side and a charge on that side. As soon as the booster ignition command is given, those fire and those nuts just separate. And they're captured by that domed material. And the reason they're captured is you don't want them flying off and hitting something as your spaceship is getting ready to leave the Earth. So they're captured in that, and those frangible nuts ride the booster up and then are pulled out when the boosters are recovered. So that's in a nutshell how the vehicle is launched. One more thing, when you watch a shuttle launch, and we'll probably see several of them on a movie in there, at the ignition of the main engines, you will see what is known as the twang effect. The main engines are like right about, I'll show you physically, the main engines that are pushing these up would be mounted right about here. So when those light, they want to push everything in that direction. And when you watch a film or video of a shuttle launch, you'll see the entire stack go in that direction. And then those do their job and keep it in place, and then it springs back. And right at the moment that the force is null or negligible, that's when they light the boosters and it takes off. So you'll see that effect on every space shuttle launch. It goes forward this way, then it comes back, and as soon as the forces are minimal, that's when they light the boosters and send it off on its way.